All right, so for this part, we are given graphs to work with, which means we have to write the equations ourselves. Okay, so this is write an equation to represent the graph shown. So I have 4 examples here. So for example number 1, first I noticed that the graph went to the left 1, 2, 3. Okay, so then the vertex in general, the vertex point of an absolute value function is always going to be the value of c, comma, the value of k, the value of d, I'm sorry. So v comma d, so c comma d. So c is what makes the graph go left and right. So it's a horizontal shift, and d is the vertical shift, meaning up and down. So then for this one, we see that from the origin, this went to the left 1, 2, 3, which means we have, this should be plus, right? So then the vertex point, so v for vertex is at -3, comma 0, okay? So then I also can tell if I use the same idea as the slope of a line, because this is, I mean, this is one side, so that looks like a line, right? But it's a line segment, but the point, I mean, it's one side of the graph, which looks like a line. So you can find the slope. So the slope is rise of 1, run of 1, rise of 1, run of 1. So that means we go up 1, we get to the graph. If we go right 1, up 1 over 1. So then the slope is equal to 1, which is the same as the value of a. Okay, so that means m and a mean the same thing, but this is so you can apply the idea of lines to absolute value functions. So then there is no up or down, right? So then the equation is y equals the absolute value. You don't have to write a 1 for a. It's implied to be 1 if you don't write it down. So this is x plus 3. And then you don't have to write the d value of 0. So this is the equation, the absolute value equation for this graph. All right, that's number 5. Number 6, notice that this went to the right 1, 2, 3, 4, 5, and then down 1. So then we have the vertex point at 5, comma, -1. So this is our c value, and this is our d value. Okay, so then let's see if we can get the value of a. So to get from this point, we go up 1, and then we get to the graph, right 1. Up 1, right 1, which means, again, the slope is 1 over 1, which means the value of a is 1. Okay, so then for this one, the function is y equals the absolute value of x minus 5, and then minus 1. And that is all for number 6. Number 7, notice this one opens down. Okay, so we see the vertex point. So the vertex is at 1, and then up 1, 2, 3, 4. So 1, comma 4. So this is our c value, and this is our d value. Also notice that this one points down, so let's find the slope. So to get to the graph, I go down, let's see, I go down 1, 2, and then over 1. So I'm dropping 2 units and then going right 1. The slope is negative because this is coming down from left to right. So then the slope is -2, which is the value of a for the absolute value function. So then the equation of this one is -2 times the absolute value of x minus 1 plus 4. Okay, so then this is the answer to number 7. Number 8, as you can see, this one is has a vertical shrink. And let's find first the vertex. The vertex point has coordinates of 1, 2, 3. So x is 3, and there is no up or down. So that means d is 0. So this is our c value, and this is our d value. And let's find the value of a. So a, to get to the graph, we go up 1 over 1, 2. And I know you can barely see it on the video, but up 1 over 2, which means the value of a, which is the same as slope of line, is 1 over 2. Which means the function for this graph is y equals a, which is 1/2, absolute value of x, and this is +3, so that means -3. And then d value is 0, which we don't have to write down. So this is the answer to, this is the function that represents this graph for one of them. Okay, thank you for watching. I'll see you in the classroom. Bye-bye.